So in this video, we're going to look at the periodic table because the periodic table contains a lot of information that we can use in chemistry, but we need to know how to use that information for it to be useful. And the periodic table has really been around for the last 150 years now. And it was discovered by Mendeleev, a Russian scientist, who saw that if you list the elements by increasing mass, you get a periodic or repeating pattern that emerges. So let's take a look at the periodic table. And this is the periodic table as we know about it today. And there's really three types of elements that we're going to look at. We're going to look at metals, nonmetals, and metalloids. So first, starting with the metals. The metals are found on the left and the middle of the table. That is where we find our metals. And metals conduct heat and electricity, and we can change their shape. They're malleable. And we can put them through wires, so they have ductility with them. For example, copper wiring, you might know about. Metals are usually shiny, that's why we make jewelry out of them. And during chemical changes, they usually lose electrons to be positive and form cations. So those are metals. Nonmetals are on the upper right-hand side of the periodic table. And there's 17 of those, and they are solid, liquids, or gases depending on what element you're talking about at room temperature, 25 Cs. And nonmetals are more or less the opposite of metals. They don't conduct heat or electricity. You cannot put them through wires or change their form. And they gain electrons to become negative anions when they undergo chemical reactions. And we call these oxidizers, which we'll talk more about in further chapters. Now, between the metals and the nonmetals, we have this zigzag line. And elements around this zigzag line are called metalloids, or semimetals, or semiconductors. And these elements have properties of both metals and nonmetals. They're good at conducting heat and electricity, better than the nonmetals, but not as good as the metals. They are not malleable or ductile as the metals, but they are better than the nonmetals. And they can gain or lose electrons. It's really just based on the reaction. So they're halfway between a metal and a nonmetal, and you can see that they actually fall right there on the periodic table. Now, when we look at the periodic table, we have different ways we can classify the elements. The first way is to split these elements into main groups, which are at the two ends of the periodic table, or transition elements. And really, the only difference between main group elements and transition elements is that the main group elements we can pretty much predict based solely on their position on the table how they're going to react. While transition elements, their properties we cannot predict as well based on their position in the table. Also, the way that we split up this periodic table, if all the elements in a column, they belong to the same group. So here we have group 1, group 2, group 3. There are 18 groups in all, either labeled 1 through 18 or 1A, 2A, 3A, 4A for the main element groups. Then we go 1B, 2B, 3B, 4B. So usually I stick to the A notation because in Gen Chem, a lot of the times we're considering the main group elements. Now, elements that are on the same row, we call those periods. So we have 7 periods and 18 groups. Now, based on what group the main group elements are, they have very different properties. So group 1A are the alkali metals, and these metals are very reactive. They're lithium, sodium, potassium. Group 2 metals are your alkaline earth metals, and they are also reactive, but not as reactive as your alkali metals. Your group 7 elements are called your halogens. They're very reactive. They're usually gases and very health hazardous. So fluorine, chlorine, bromine, iodine. And group 8 are your noble gases, and these gases are non-reactive. We call those inert. Now for the periodic table, for these main group elements, we can really predict what charge their ions are going to have. And main group metals, they lose electrons and become positive, as shown here, so they're cations. Non-metals tend to gain electrons and then become anions. And we can usually predict how many electrons are usually gained or lost, because these main group metals, they want to lose electrons to have the same number of electrons as the nearest noble gas. So for lithium, we lose 1 electron to become a noble gas. Calcium, we need to lose 2 electrons to become a noble gas. While nonmetals, they gain electrons to have the same number of electrons as the nearest noble gas. So fluorine gains 1 to become a noble gas. Oxygen gains 2. So that's something to keep in mind. If an element loses electron, think of it going to the left on the periodic table. If it gains electrons, think of it going to the right. And the goal of these main group elements, when they are ions, is to look like noble gases. All right, that's it for this video. See you in the next.